Hello my lovely students, you're welcome to a new lesson. Today, I shall be teaching you quadratic functions or graphs. From definition, a quadratic function is a function in which 2 is the highest power of the unknowns. Also from definition, a quadratic function is a function of degree 2. That is, the highest exponent of the function is 2. The general form of a quadratic function is y equal to ax squared plus bx plus c. Let's learn more about quadratic functions or graphs. Looking at the information on the left hand side, the quadratic function y equal to ax squared plus bx plus c produces a minimum curve. From the graph on the left hand side, we have a minimum curve having a U shape or a cup shape with a minimum point. Also from the information on the right hand side, the quadratic function y equal to minus ax squared plus bx plus c produces a maximum curve. From the graph on the right hand side, we have a maximum curve having an N shape or a cap shape with a maximum point. That means that a quadratic function can either produce a minimum curve or a maximum curve. Please take note of this information. Moving on, let's learn about the 3 types of roots that a quadratic function can produce. The graph or curve of a quadratic function produces the following types of roots with respect to the x-axis. Number 1 type of roots are the real and distinct roots. Number 2 type of roots are the equal roots, that is, the real and equal roots. While the number 3 type of roots are the imaginary or complex roots. Please take note of these 3 types of roots that a quadratic function can produce. Taking the definitions, number 1, real and distinct roots. This occurs when the graph or curve of a quadratic function cuts the x-axis in 2 distinct, clear and different points. Here is an example of a graph or curve of a quadratic function which produces real and distinct roots. We consider the graph or curve cuts the x-axis at 2 different points. We can tell a quadratic function which has real and distinct roots when b squared is greater than 4ac, or when b squared minus 4ac is greater than 0. Don't forget, a is the quotient of x squared, b is the quotient of x, while c is the constant term in the general form of the quadratic function. Looking at the second type of roots that a quadratic function can produce. Number 2, equal roots. That is, real and equal roots. This occurs when the graph or curve of a quadratic function touches the x-axis at 1 point. Here is an example of a graph or curve of a quadratic function which produces equal roots. You can see that the graph or the curve touches the x-axis at 1 point. We can determine that a quadratic function produces equal roots when b squared is equal to 4ac, or when b squared minus 4ac is equal to 0. Look at a third type of root which a quadratic function produces. Number 3, imaginary or complex roots. This occurs when the graph or curve of a quadratic function does not touch the x-axis and there are no real roots. This is an example of a graph or a curve of a quadratic function which produces imaginary or complex roots. You can see that the graph or the curve does not touch the x-axis, making it have imaginary or complex roots. We can tell that a quadratic function will produce imaginary or complex roots when b squared is less than 4ac, or when b squared minus 4ac is less than 0. Once again, a represents the coefficient of x squared, b represents the coefficient of x, while c represents the constant term in the general form of the quadratic function. I hope this idea is clear to you. Moving on, let's take our first example on quadratic functions or graphs. Example 1. Without drawing the graph or curve of the following quadratic functions, determine if they have a. real and distinct roots, b. equal roots, c. imaginary or complex roots. The first quadratic function is y equal to x squared minus 5x plus 10. The second quadratic function is y equal to minus 4 plus 4x minus x squared, while the third quadratic function is y equal to 3x squared minus 8x minus 7. Please, before we move on, can you still remember the formulas that we can use to determine whether a quadratic function has real and distinct roots, or equal roots, or imaginary or complex roots? Let's see if you can still remember. Taking the solution to the first quadratic function. The quadratic function is y equal to x squared minus 5x plus 10. In this quadratic function, a is equal to 1 because it's the coefficient of x squared, b is equal to minus 5 because it's the coefficient of x, while c is equal to 10 because it is the constant 10. Now let's note two values. The first value is the value of b squared, which is minus 5 squared, which is equal to 25. The second value we are to note is the value of 4ac, which is 4 times 1 times 10, which is 40. Now, to determine the nature of the roots of the first quadratic function, let's compare the value of b squared and 4ac. What do you notice? Comparing the values of b squared and 4ac, you will note that b squared is less than 4ac because 25 representing b squared is less than 40 representing 4ac. Or you will also notice that b squared minus 4ac is less than 0 because 25 minus 40 is less than 0. That means the quadratic function has imaginary or complex roots. I hope you got that right. Let's see the solution to the second quadratic function. The second quadratic function is y is equal to minus 4 plus 4x minus x squared. The first thing we have to do here is to rearrange the quadratic function. So it becomes y is equal to minus x squared plus 4x minus 4. Now after rearranging, the value of a, which is the coefficient of x squared, is minus 1. b representing the coefficient of x is 4. yc representing the constant term is minus 4. Once again, we need to know the values of b squared and the value of 4ac. The value of b squared, which is 4 squared, is 16. The value of 4ac, which is 4 times minus 1 times minus 4, is also 16. Now comparing the value of b squared, which is 16, and the value of 4ac, which is also 16, you will notice that b squared is equal to 4ac, or b squared minus 4ac will give you 0. Now that we know these facts, can you tell the nature of the roots of the quadratic function in y equal to minus 4 plus 4x minus x squared? Let's see if you can. Now, since b squared is equal to 4ac, or b squared minus 4ac is equal to 0, the quadratic function has equal roots. I hope you got that right. Let's see the solution to the last quadratic function, which is y is equal to 3x squared minus 8x minus 7. Now in this last quadratic function, can you tell the nature of the roots here? Let's see if you can. In the third quadratic function, y is equal to 3x squared minus 8x minus 7. Here a is equal to 3, b is equal to minus 8, yc is equal to minus 7. Taking note of the value of b squared, we have minus 8 squared, which is 64. Also taking note of the value of 4ac, we have 4 times 3 times minus 7, which is minus 84. Comparing the values of b squared, which is 64, and 4ac, which is minus 84, we can see that b squared is greater than 4ac, or b squared minus 4ac is greater than 0. That means that the quadratic function has real and distinct roots. I hope you got these solutions correct. I hope these solutions are clear to you. Moving on, let's learn about the tangents, gradients, and line of symmetry of a curve. Number 1, tangent. A tangent to a curve is a straight line that touches a curve at one point only. Number 2, gradient. A gradient or slope of a straight line is a measure of the steepness of the line. The gradient of a line passing through points x1, y1 and points x2, y2 is as follows. The formula for gradient is y2 minus y1 divided by x2 minus x1, or y1 minus y2 divided by x1 minus x2. This formula for gradient represents the difference in the y coordinates divided by the difference in the x coordinates. Please take note of this formula for gradient. Number 3, line of symmetry. A line of symmetry of a curve is a straight line that divides a curve into two matching halves. Please take note of these three definitions for tangent, gradient, and line of symmetry of a curve. Let's look at our last example, example 2. Question A. Prepare a table of values for the relation y is equal to 2 plus x minus x squared for values of x from -2 to 3. Question B. Using a scale of 2 cm to 1 unit on both the x and y axis, draw the graph of y is equal to 2 plus x minus x squared. Question C. From your graph, find the gradient of the curve at the point where 1. X is equal to 0, 2. X is equal to 2. Question D. What is the equation of the line of symmetry of the curve? Let's see the solution to example 2. Looking at the solution to question 2a. Let's see the table of values for the relation y is equal to 2 plus x minus x squared. Don't forget the values of x, they are from -2 to 3. That makes x to be -2, -1, 0, 1, 2, and 3. Now completing your table of values, you are going to have the corresponding y coordinates, which are when x is -2, y is -4. When x is -1, y is 0. When x is 0, y is 2. When x is 1, y is 2. When x is 2, y is 0. And when x is 3, y is -4. So from this table of values, let's draw the graph of y is equal to 2 plus x minus x squared using the scale mentioned in question 2b. From question 2b, here is the graph of the relation y is equal to 2 plus x minus x squared. Of course, the relation or the quadratic function should produce a maximum curve because the coefficient of x squared is negative. So your graph for the relation should look like this. Now, let's see the solution to question 2c. Let's determine the gradient of the curve at point x is equal to 0. To determine the gradient of the curve at x is equal to 0, you are going to draw a tangent line. That is a line that will touch the curve at just one point, where x is equal to 0. You need to be very skillful to do an accurate work here. From our graph, the line that is tangent to the curve at x is equal to 0, that line is PT. Let point 1 be P, having the coordinates x is 0, y is 2. That makes x1 to be 0 and y1 to be 2. Let point 2 be T, with coordinates x is -2, y is 0. That makes x2 to be -2 and y2 to be 0. Once again, the formula for gradient is y2 minus y1 divided by x2 minus x1. Substitute the values for x1, y1, x2 and y2 into your formula for gradient and calculating, you are going to see that the gradient of the curve at point x is equal to 0, the gradient is 1. Next, let's see the gradient of the curve at the point where x is equal to 2. Here what you have to do, you have to draw a tangent line to the curve at the point where x is equal to 2. Once again, you need to be very skillful to do an accurate drawing. From the graph, you will notice that the tangent line going through the point where x is equal to 2 will pass through points Q and R. Let point 1 be Q, having the coordinates x is 2, y is 0. That makes x1 to be 2 and y1 to be 0. Let point 2 be R, having the coordinates x is 3, y is minus 3. That makes x2 to be 3 and y2 to be minus 3. Now, using the formula for gradient, which is y2 minus y1 divided by x2 minus x1, substituting your values into your gradient formula and solving, you are going to see that the gradient of the curve at the point where x is 2, the gradient is minus 3. Lastly, let's see the solution to question 2D. Let's know the equation of the line of symmetry of the curve. The equation of the line of symmetry of the curve is equal to the average or mean value of the roots. From your graph, you can see that the roots of the quadratic function are x is minus 1 and x is 2, because the curve crosses the x-axis at minus 1 and 2. Now, to tell the equation of the line of symmetry of the curve, we are going to find the average or the mean value of the roots. That means adding the two roots together and dividing by 2. So the equation of the line of symmetry of the curve is minus 1 plus 2, all divided by 2. That should give 1 divided by 2, or 0.5. That means the equation of the line of symmetry of the curve is x equal to 1 over 2, which is half, or x is equal to 0.5. I hope all these solutions are clear to you.
Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic quadratic equations, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.